continuity. Continuing further with continuity. You see, continuity means what we see previously. The graph of a function will go and go on. We need to check whether that function is continuous at a particular point A. If x tends to A, this f of x tends to f of A means here it touches and we find the value f of A, then it is continuous. Okay, suppose the function is going like this. Here we have the point A. Here when x approaches A, when we reach here, any f of A will exist here? Maybe there. See the diagram, man. There is a hole. Nothing is there. The function is not defined at this point. So it is not continuous. Okay. But how do we denote it? See. From here if we approach means that is A minus. From here from we approach means A plus. From here if we approach means that is A minus. This is A plus, this is A plus. Because A plus something means we get the other point, this neighborhood. So why I am telling this means this set of points there, right? The points which slightly above the A, below the A. That points and all, this set, this interval is called as neighborhood of A. What is this? Okay. See, the neighborhood of A means the value of x. The value of x that will lie between this A plus, let it be A plus h something. Here A minus h. Between this only this value lie. A small interval. Okay, of some radius. So a function is defined in this kind of neighborhood. And we are going to check the differentiability of the function. What is derivative? The differentiability of the function. How to check? See, differentiation of this function is nothing but it is a slope of a tangent. Tangent means it touches the curve at only one point like this. Okay. For this line we are finding slope. Also it's a matter of progress from one point to another point. Differentiation means it is a rate of change. Means what? At what rate it is changing. You think of curd. You like curd rice? How that curd has become curd? It has obtained some change. Is it or not? So depending on some situation, some conditions, the milk will turn itself into a curd. Is it or not? So considering depending on what the milk will turn into curd. This is the time. Time goes and goes and goes and goes on, we'll get the curd. Clear? So it is a rate of change. At what rate it is changing? See, here also, that change you are plotting it as a graph. In that, this is the point A, this is some random point x. This is the point where we can get the curd. This process is going and going and going. So, by what time we get the curd? By what rate it is changing? That we need to identify. Okay, as I said, it is slope of tangents. You'll just mark these points. This is f of x. This point is a. That point is f of a, and this point can be denoted as x coordinate, y coordinate. X is x. So x comma f of x. This is this particular point. That is a comma f of a. So slope of tangent I said, right? Mark, this is x1 y1, this is x2 y2. That is the formula for slope. That is y2 minus y1 divided by x2 minus x1. Okay. So here what is y2 here? F of a minus what is y1 here? F of x divided by what is x2 here? A minus x. Okay, this is the rate of change, slope of the tangents. We call this as derivative. Okay, and the limit x approaches a. X is approaching a. Instead of taking this x and f of x here, if I took that the other side means I may get, or else from this itself you take minus out from, we are going to get the formula. You take the minus out from the numerator and denominator. What we will get? Yes, that is what we will get. See, limit x tends to a, f of x minus f of a divided by x minus a. Okay. Okay. Is that all right? Is that all right? Okay. See, we say this particular function is differentiable, derivable, when this limit exists and finite. If this limit exists and finite, I think you may recall things from limits, continuity, and now differentiable. Everything is interconnected. Okay. So this limit exists and finite, we may say it is differentiable function. Okay. What is this limit actually? Slope of a tangent. Slope of a tangent. For that tangent only, that tangent exists means this is differentiable. Sometimes the function will have two different values. Like you may have seen functions like f of x is equals positive x when x is greater than 0, minus x when x is less than 0. Remember this type of functions? So at certain point it may take a turn. Right? There may be some breaks will happen. We need to find out, figure that out. Like the way we done in the continuity chapter. Remember, continuity, we see all the algebraic functions, all the polynomials are continuous, and we will check only at this point what point mentioned here. Can you recall? Likewise, in the case of differentiability also, for this type of function, we are defining two types of derivatives. One is left hand derivable, other one is right hand derivable. Okay. Can you guess what could be left hand derivative and right hand derivative? Same like the continuity we done, right? So LHD, that is left hand derivative, means limit x tends to, left means is that a minus or a plus? I told you, right? A minus f of x minus f of a divided by x minus a will be exist. If this exists, we say that function has left hand derivative. Okay. So in terms of h, if you want to say, means limit h tends to 0 f of a minus h minus f of a divided by minus h. In place of x, I substituted a minus h, that's all. That is what happened, you see. In place of x, I substituted what? A minus h. Then here what will come? A minus h minus a will come instead of x. So this plus a minus a will get cancelled, we get minus h. Okay. So it is left hand derivative. Left hand derivative. What is right hand derivative? Any guesses? Any ideas? Shall I erase this? No man, here I will write. See, you have to copy this and all. Or else this example not needed at this moment. Use this case. See, right hand derivative means what? Limit x tends to a plus, right hand means a plus only, right? F of x minus f of a divided by x minus a exists and finite, because after the point a it exists and finite. Then we may say it is having right hand derivative, right? So that is equals limit h tends to 0 f of a plus h minus f of a divided by h. This will exist and finite. Any doubts in this? See, the neighborhood of a, one function is defined. We need to check whether the function is having derivative at the point or not. We are going to check. Okay. For that, if that is directly derivable, like the same function means it is not having any two outputs, means we can use this. We check whether this exists or finite. The tangent, slope of the tangent exists or finite. We just find out. Suppose it has two different values. It has a break maybe. So then we have left hand derivative and right hand derivative. And what do we say? We say that type of function is derivable. That type of function is derivable when this right hand derivative should be equal to left hand derivative. Then only we can say. Otherwise, we can't say. Clear? So a function f is differentiable if this right hand derivative equals left hand derivative. If and only if. Okay. Any doubts in this? Suppose this is not equal, we may say it is not differentiable. Yes. See, start writing now this graph. Doubt. Okay. See, I will draw this graph once again. See, man, this is the curve of the function, right? In this curve, let us mark some random point A, some random point x, or else here x, here A, let me mark. So from this point to that point, what change has been happened? From this point to that point, what change has been happened, we need to calculate. How do we calculate? See, ups and downs are there. How do you measure? If this is a point, means here how will you calculate the change? Change means length. End product minus starting. End point minus starting point, right? So likewise, see, this x is approaching A. How much change will happen, that we are going to measure. So when here x is, this point on the curve is f of x. Okay. So the point as a ordered pair, will take it as x comma f of x. And this point here A means at the curve it is f of A, right? Simple, man. Y is equals f of x, is it? When x is equals x, it is f of x. X comma f of x. When x is equals A, y is f of A. So it is A comma f of A. Now we are about to measure the change happened between these 2 points when x approaches A. That how do we find out? By finding the slope of the tangent. Slope means what? Like this, whenever 2 points between these 2 points, we need to find slope, means this formula we should apply. That is y2 minus y1 divided by x2 minus x1. Here 2 points we have. This first point is x1, this is y1, this is x2, this is y2. Then substitute accordingly. Then you may have f of a minus f of x divided by a minus x. Is it? y2 minus y1 by x2 minus x2. Now this is the formula. I took minus out from both numerator and denominator. Okay. If this one exists and it is finite, we say there change has happened. It is differentiable. Okay. Clear? Up to this you got clarity. Now suppose the function is having break at this point between this. Somewhere the curve is going like this. Like here one break will happen. From this point upwards it will continue. The function having two different outputs. Remember? When x greater than 0, x less than 0, like this. For that, how to check? Left hand derivative, right hand derivative. Okay, right hand derivative means instead of a, it is a plus. Left hand derivative means that is a minus. Clear? Any doubts on this? You just finish writing everything. Start from the neighborhood definition.